This is Mr. Rowe. We're looking in geometry part A. This is lesson 17, and we're going to talk about how to prove a quadrilateral is a parallelogram. This is some of the information covered in the lesson content. Just want to explain it to you in a little different way to help you get through the assignments. Let's take a look at what we actually have to do here. So what do we need to show in order to prove that a triangle, or not a triangle, but a quadrilateral is a parallelogram? Well, there are several theorems that we looked at in the lesson. And so here are some of these things. Well, the first thing is if you can show that both pair of opposite sides are parallel, that's the definition of a parallelogram. So if you can show that, then you can prove that the quadrilateral is a parallelogram. The next thing we talked about was showing that both pair of opposite sides are congruent. So this was theorem 17-5. So if we can show that the sides are congruent to each other, then we can show that the quadrilateral is a parallelogram. So the next one was if one angle is supplementary to each of its consecutive angles. And this was theorem 17-6. So we got this angle right here, and it is supplementary to both of its consecutive interior angles, or consecutive angles. I use the word consecutive interior because this is a parallelogram, so these lines are parallel, and so are these. So I kind of use that interchangeably. I shouldn't, but I do. So these lines are these angles are supplementary to each other. So the next one is both pair of opposite angles are congruent. Now remember, the opposite angles are across the quadrilateral from each other. So this pair right here would have to be congruent. Then we would have to show that these are congruent. So if we can do that, then we can show that this is a parallelogram. So the next one is to show that the diagonals bisect each other. This is theorem 17-8. So this, simple theorem here. If you have the diagonals and they bisect each other, so the two segments are congruent, so like these two are congruent, and then these two are congruent, then we can say that the quadrilateral is a parallelogram. And then finally, probably the most useful theorem to show that a quadrilateral is a parallelogram, because this one's so easy to do with triangles. If we can show that one side is both parallel, so this triangle means it's parallel, and congruent, then we can say that this quadrilateral is a parallelogram. So we're going to look at two proofs. You'll have similar proofs in your lesson or in your assignment using some of the same thought processes and same techniques. You'll have to show that two quadrilaterals are parallelograms. So let's take a look at our first example. So here is our picture. So we want to use this given information that QR is parallel to PS. So here's QR, it's parallel to PS, and that QT is congruent to ST. So QT right here is congruent to ST. We're going to use that to prove that the quadrilateral PQRS is a parallelogram. Now remember, we always want to start off with thinking out what we're going to do. Once we think out what we want to do, then we start with our statements and reasons or our flow proof. So in this case, we're going to do a two-column proof. So based on what I see already, I've already got a side congruent to a side. I can use that this is a set of parallel lines. I can get this angle right here is congruent to this angle right here. So I've got an angle, a side, and then if I use this vertical angle right here, I'll have angle, side, angle congruence. Now what does that do for me? Well, once I can prove that these two triangles are congruent to each other, then I can say that these sides are congruent. So once I can show that those sides are congruent, I was given that they're parallel. If I can prove that they're congruent, then by that last theorem we just talked about, 17-9, we can say that the quadrilateral is a parallelogram. So that's what we're going to do. So let's start off with our statements and reasons. So we always start off with something that's given. So we're given that segment QR is parallel to PS. That's given. So based on the fact that those are parallel, that's where we get these angles are congruent to each other. So that's going to be my next statement. Angle RQS right here, RQS is congruent to PSQ. So those two angles are congruent. Now what's the reason for that? Since these lines are parallel, then that's by the alternate interior angles theorem. Again, something from a previous lesson is coming back to be used in this lesson. That's the great thing about geometry. Once you use something, you're going to use it later on. We don't learn things in isolation. So I got this other piece of given information. That QT right here is congruent to T or ST. Well, that's a given piece of information. So that's my angle and that's my side. Well, I got this other angle we talked about, so we're going to write that down. So angle QTR, right there, QTR, is congruent to STP. So these across from each other are vertical angles. Vertical angles are always congruent. So that's by that theorem. And again, we learned this theorem early in the course. So vertical angles are congruent. That's something way back. So we're bringing it back here again to use. So we've got a triangle congruent because we've got angle, side, angle. So that's what we're going to say next. Triangle QTR is congruent to triangle STP. And what is that reason? Angle, side, angle. So remember we talked about this not too long ago in proving triangles are congruent. So we're pulling that back. Now based on that, we can now say that QR is congruent to Q or PS. And what is that reason? Well, we talked about this in the lesson, but there's something called corresponding parts of congruent triangles are congruent. So to shorten that up, we use this little abbreviation CPCTC. Congruent parts of congruent triangles are congruent. So that's what that means. You might want to write that down. It's in the lesson content, so take notes on that when you read that. So based on that, the fact that we have a side congruent and parallel to the opposite side, well, we have that PQRS is a parallelogram by that theorem. If a side of a quadrilateral is parallel and congruent, then the quadrilateral is a parallelogram. So that's our first proof. You can just write that theorem since we're talking about this lesson and we've got everything numbered, so you can just write the theorem, theorem 17-9. You don't have to write out this whole theorem. So that's the first proof. Remember to walk through that process just like I did. Let's take a look at our second example. So here is our triangle. Looks like we're given something about parallel lines and congruent angles. So here we're told that H is congruent to J. Angle H is congruent to angle J. So we've got angles across from each other. And then we've got that HI is parallel to KJ. So what we want to prove is that HIJK is a parallelogram. So how are we going to do this? Well, let's start with our thinking process. Because these two are parallel to each other, well, that means that these two angles right here must be supplementary. And so do these. So these two angles are supplementary to each other, and that's consecutive interior angles theorem. So since I already know that these two have to be congruent to each other, what I'm going to do is I'm going to use substitution to show that the same angle is congruent to both of its consecutive interior angles, or consecutive angles. And so that's our thought process, and that's how we're going to do it. So let's start off with the fact that HI is parallel to KJ, and we're using a flow proof this time. So that's given. Based on that, remember I said that these two angles have to be supplementary to each other. So H plus K has to equal 180 degrees. And what's the reason for that? Well, consecutive interior angles theorem. I also said the same thing about the other two angles. So I and J have to be supplementary as well. So we're going to say that. So the measure of angle I plus the measure of angle J also has to be 180 degrees by the same reason, consecutive interior angles theorem. All right, so I'm given something else about angles. I'm told that H is congruent to J. So that's given. Based on that, I know that the measure of the angles are congruent. Now, yes, you do have to state this. You can't just jump straight to that. That given piece of information tells me this. And that's by definition of congruent angles. Now, based on this, I can replace in this statement right here, I can replace H with J. So I've got the measure of angle I plus the measure of angle H. So you see I replaced H right there. I substituted J for H. And what tells me I can do that? Well, that's the substitution property. And so once I have that, now look at this. I have that both of these angles, or the H, is supplementary to I and K. So H right here is supplementary to I, which is a consecutive angle, and K, which is a consecutive angle. So based on that, I now know that the parallel, or the HIJK is a parallelogram, and that is by that theorem 17.6, which says that if an angle is supplementary to both of its consecutive angles, then the parallel, or the quadrilateral, is a parallelogram. So this is the thought process you're going to have to use for your proofs in the lesson. I hope this helps you walk through those two proofs. If you struggle with those proofs, please set up an appointment for a help session, but definitely let me know in a teacher message.